Data centers with conventional computing technologies are taking up a larger and larger fraction of the world's electricity resources, and increasingly now water as well to keep them cold. A way to get around this would be to replace them with computers that operate at very low temperatures, made from superconducting materials, as these can operate at much higher energy efficiencies, up to 100 times less power used, even if you account for the amount of power needed to keep them cold. A serious problem for this, though, is that that sort of memory for operating at these low temperatures just does not exist at the scale to make them possible industrially. With the materials research that we've been doing at Paihau Robinson and the School of Chemical and Physical Sciences at Victoria University of Wellington, we believe we have materials to develop exactly the cryogenic memories which are needed to make the superconducting computing a real technology into the future. We've been working on these materials for almost 20 years. We have the world-leading understanding of their properties. Recently, we've started turning them into prototype memory devices that show exactly the characteristics needed to make the technology a reality. We've even started integrating them with other forms of superconducting electronics, which will be needed to build a full superconducting computer. We've been making connections to international researchers and especially to some international companies in the market area of developing superconducting computing. We have a plan for developing the technology to the point of a commercial reality over the next 5 years, where we expect to be producing prototype devices for a number of markets. And if we get the right amount of support, then we'd expect that roughly 10 years from now, we'll be producing cryogenic memories for superconducting and quantum computers around the world.